Food waste is becoming increasingly concerning. According to the USDA's Economic Research Service, in 2010 there was 31% food loss at the retail and consumer levels, equating to 133 billion pounds and $161 billion worth of food. These numbers are only increasing as time progresses. This also poses a problem for the environment. When food is thrown into landfills, as it is in almost all schools and institutions, it promotes the release of methane. In the US alone, food waste in landfills contributes to the same amount of greenhouse gas emissions as does 36 million cars. Restaurants specifically are found culpable. For instance, in New York City alone, more than 33% of the city's daily trash is food waste, and restaurants account for 70% of this waste produced by businesses. In 2017, our co-founder Shivani Patel looked into the solution of composting when she created her own backyard compost. She soon found that, though composts are a popular solution in eliminating raw food waste, there were many parameters that restricted her from composting cooked foods, poultry, or dairy in an eco-conscious, efficient, and economical fashion. Plus, she wasn't exactly keen about attracting maggots to her backyard. Traditional aerobic compost piles will produce odors and attract pests when composting anything but raw food. The second most popular option, bokashi composting, is a Japanese technique that uses microorganisms to break down food through fermentation. However, bokashi composting only creates a pre-compost substance that can produce odor as well. Enter EcoCompost. EcoCompost is a revolutionary composting device that can decompose all types of food waste on a large scale. With this design in place, food processing costs can be cut significantly for restaurants, and farmers can find an inexpensive and accessible way to obtain organic fertilizer. EcoCompost was designed to optimize essential aspects of the composting process. Heat is an intrinsic element in composting. Thermophilic bacteria digest material most efficiently at 160 degrees Fahrenheit. Deviation from this number can result in slower compost time or destruction of beneficial microbes. High temperatures allow pathogens and weed seeds to be destroyed. However, if the heat becomes too high, nitrogen supply in the soil depletes. In an attempt to maintain the most amount of heat in the system, EcoCompost is insulated with fiberglass, allowing for composting any time of the year. Oxygen is also necessary for aerobic decomposition to work efficiently, so internal tubing was added to allow outside air in. Unfortunately, this lowers the temperature of the compost, especially in colder climates. This is counteracted by the addition of heat lamps. These lamps are controlled by a heat sensor which measures and displays the internal temperature of the compost and is programmed to increase or decrease the intensity of the heat lamps so the temperature is controlled. pH must be maintained since divergence from a pH of 6 to 7 hinders the growth of many plants. Acidic compost is caused by lack of oxygen supply. EcoCompost has a pH sensor which measures hydrogen ion concentration. It is programmed to increase rotation and oxygen flow to prevent acidity. In order to make EcoCompost completely independent of non-renewable resources, the rotation of the bin is powered by solar energy. The exterior of EcoCompost is covered with monocrystalline 200-watt solar panels that absorb photons. This will be converted to kinetic energy and used to rotate EcoCompost at 5 full rotations in an hour. EcoCompost operates as a business-to-business. The market we plan on targeting is the farming industry. Right now, there are 570 million farms in the world, 90% which are owned by individuals or families. Based on data collected about the fertilizer market and current farming industries, we plan on reaching 1% of these farms in the next 10 years, which corresponds to 5.7 million farms. Currently, we are in contact with 3 family farms and exploring the possibility of the role of EcoCompost on the farms. The cost of creating 1 unit of EcoCompost would total around $380. We plan on selling each EcoCompost for $700 to result in a 45.7% profit margin. This is competitive with other quality composts, like the drawer compost, which sells at $849 for a 14.2 cubic feet compost. As for the future, we plan on funding by contacting venture capitalists and angel investors, as well as submitting our concepts to different competitions. We also plan on furthering research and development to develop the optimized prototype. Lastly, we plan distribution by curating contracts with local farms and waste management companies so that more people can know about our product. The EcoCompost team is currently comprised of 2 juniors, Shivani Patel and Phoebe Chen, both attending the same STEM magnet school. The 2 members have developed a deep-rooted interest in biology, engineering, and of course, entrepreneurship. We hope you can help support EcoCompost's journey. Thank you.